Welcome to my channel. Today I'm looking at how to calculate centroid of a beam, and that is the given beam. And we've got some given information of a point load of 10 kilonewton, uniformly distributed load of 12 kilonewton, and the beam has a length of 5 meters, and also our E is equal to 210 gigapascals. So let's solve it. So for now to calculate the centroid of the beam, we're going to use this formula, where AT is the total area for the whole material, and Y bar, that is total centroid for this material. And also now we can see that AS, that is the area for the solid part, and A1, that is the area for this square, and for the rectangle it's A2. So Y bar 2, that's the centroid for this rectangle, and Y1 for this square. So we're just going to substitute it from the information that we have to get what we want to have. So for the total area, we say it's area of the solid part, and subtract it with area for square 1 and the other 2, and here is the total Y bar, and equate it to area of the solid minus that A bar solid and A1 Y1 bar and A2 Y bar 2. So let's go now for the area at AS. We got that from 100 plus 2, 3, 4, 6, 7 is 700 millimeters per 1000, that is 0.7 meters. So it's 0.7, and we multiply it by total base, that is 0.532, right? And we're going to subtract for the square is 0.2 multiplied by 0.2, and subtract for the rectangle, it's 0.2 multiplied by 0.4, 0.2 multiplied by 0.4. So Y bar total, this must be equal to this equation, right? So this whole equation, it says AS, subtract it with A1, A2 by Y bar T, that is what we got here, and we're now left with this part. So we're going to punch this whole thing in the calculator and get what we get, and what to take there and equate it the whole equation, right? So if we come with calculator, and 0.7 multiplied by 0.532, this one, and subtract that, got something like, say, Y bar, it's 0.2524, yeah. And now we're going to equate it with this part now. So it's equal to AS, Y bar S, and A1, Y bar 1, and A2, Y bar 2, right? We keep on moving now. Y bar, now we've got the fig for this one, 0.2524, and equate it to the area of the solid part. We calculated it here, right? So if we punch these figures individually, right, we got for AS with 0.3724 Y bar for the solid part, and we're going to subtract for area 2 is 0.2 squared Y, okay, by 1, and for 2 it's 0.08 squared by 2 bar, right? So now I've got this thing now, it's halfway down. We're just using our calculators and substituting it. For ys bar, that is the centroid, is 700 divided by 2, and for y1, right, it's 200 divided by 2, and for y2 it's also 200 divided by 2. So just substitute those figures. So we say y bar 0.2524 will equal to 0.3724. For the solid part is 0.7 over 2, right? And for this one 0.2 squared, and it's 0.2 over 2 is 0.1, and for this one also 0.08 squared multiplied by 0.1. Get it now? So if you point these figures in calculator now, we got y bar t, that is the total y bar, that is the one we are looking for now. It's now easy, as you can see. So and it is multiplied by 0.2524, right? It will be equal to, let me just punch these figures in the calculator, right? 0.37 multiplied by this one. We've got something like 0.09434, right? So for us to now get the y bar total, that is the centroid for the whole material, we're going to divide by 0.2524, and also here we're going to divide by 0.2524. So this one cancel and then that one divide that one. Y bar total now will be, let's use our calculator, 0.09434 divided by 0.2524. We've got something like, it's 0.37377 meters, right? So this is the centroid for the whole material. It's now solved.